This is a test of the microphone. This is a test of the microphone. Test. We should be live. Can I hear myself? Mic check number 2. Test. We should be live. Can I hear myself? Any comments about the volume? It's good volume. Mic check number 2. Test. We should be live. Can I hear myself? Any comments about the volume? It's good volume. Mic check number 2. Test. We should be live. Can I hear myself? Any? Thanks, Mario. All right. This one, yeah.
Even know what this talk was going to be about, but I was like, every time Ambrose talks, I end up having my brain fail. So
Play slideshow in. Is this it? Okay. Okay. Oh, I'm gonna gather myself for a second. Where did I put my water? There. Oh. All right, I'm going to start. So thanks all for coming for this very strange time. It is technically lunch here, so we should all have our hour off because we're in Europe, of course, you know, and we eat, we never work while eating. But this, I planned this talk about a week and a half ago when I got some really good news that I got funding from Clojure Together to work on Malli that I recently became a maintainer for. And that's, I can't really express how exciting that is given how widely used Malli is. And along with my maintainership of schema and type Clojure, it's sort of, I feel like I can be a real use to the community. And hopefully this is, you know, just the beginning of many years of I don't know, improved verification for Clojure. Not necessarily static, not necessarily dynamic. It's all fun to me. So yeah, this is work that I prototyped back in April, and I've tried to load it back in my brain in the last week, and so this is really me using, this is talk-driven development right now. Like, this isn't necessarily going to be my make sure a 5-year-old with no computer science knowledge understands my talk. This is, I'm going to assume that you know a bit of Malli, and if you don't, just raise your hand or, and we'll tackle that particular problem, or, you know, solve the question you have. What else? Yeah, and this talk is really rough, so just stop me if you need to. But I'll try and overcome the lack of preparation I've done on the slides. Okay, so this talk is about constraining Malli schemas. So Malli is a Clojure library for verifying programs using runtime verification. Malli has a specification system called schemas, where you write what your program is expected to do. And this talk is about essentially making these schemas more expressive to be able to have more fine-grained specifications. Okay. This is basically what I just said. So Malli provides a DSL, which is schemas. When you write a specification, you get all this stuff for free with Malli. You get validators, which is you get predicates, whether something is or isn't conforming to that specification. You get explainers or humanizers where it will explain to you in English whether the reason why your program doesn't conform to the specification. It gives you generators to give you examples of the specification that you've written down. Parsers, parsers and coercers, they're more, I don't have a single line example for that. Oh, hey. So the problem we're tackling here is that certain specifications are sort of too precise. That should say too precise. And we can't actually specify them in Malli at the moment without resorting to what I call hacks. And what I mean by a hack is anything that makes a specification work with an asterisk. Like, oh, it works, except the generator doesn't work and the explainer doesn't work and the coercer's weird or something. Or I'm sure if anyone's used Malli, you know that you sort of, it's all well and good until you just want one extra thing, and then you have to use one of these hacks and you get all the benefits, well, many of the benefits are nullified. And actually, in practice, you don't really notice it because usually validators work just fine, which means coercers work just fine. So what actually happens is your users end up suffering. They tell you, hey, my error message just got really bad. You know, your tests seem to pass because the validators work. So it's a big problem in Malli, in real world Malli. And if you look at the Clojurian Slack channel for Malli, it's often, how do I make this specification more granular? And the answer is use a hack that destroys these properties. So here's a good example. So there's a lot here, but let's just zoom in on the last line. So this is a schema that says, this is a conjunction. It says, this is an int that is greater than 739 and less than 741. So only 740 lives in here. But the way that, I'm skipping a bit of context here, but I'm going to explain this first. So the way that, so this sample function gives you examples of values that are of this type, and it should be of this spec. It should just be 740, 740. Sample gives you a list of samples. But what actually happens is generators, and this is true in Clojure spec as well, work directionally. You actually generate values from int_har, and then you filter values that are within these bounds. So you could generate 0, 1, 2, 3, 4, and then it's like, oh, we need to bump up, if you know test check, it has a size. So it'll go, well, 1 million, 1 billion, 1 trillion. Nowhere near it, and you'll get this exception that I haven't written here. It's something like such that tried 100 times. Every Clojure developer has seen that. You'll only get that if you have a generator that is basically probabilistic in its success. And this has almost no chance of success. And I think I have an example later on with doubles as well, with floating point numbers. But as a bit of a teaser, if we sort of reformulate the way that we think of specifications as a schema has properties inside of it, has constraints, then there is actually an implementation pathway to be able to reliably generate 740. So this says an integer that is basically 740 between these two bounds. But because the way that Malli is built, the generators for schemas are implemented by the schemas themselves. So the AND schema doesn't know anything about int. But the int schema is in charge of generating values at this point, so it can do something clever. So a couple of other examples that I've seen on the Clojure in Slack. So schemas for maps allow you to specify optional and required keys, but often you want something a little more granular. You want, well, how about if I give this one, I want this one, or like use a password, or there's tons of examples in this talk. So I'll just, I'll look forward to that. And there are two hacks, and together they perform the most damage. One is called and one is called fun. So fun is basically the specification is a program, which is all well and good for, it's runtime checking, but you can't explain automatically why a program went wrong. You can't generate automatically values that will pass a program. Maybe not in this lifetime, So yes, and the two problems that I'm highlighting in this talk: generators become unreliable, error messages must be customized. And anyone who has Malli in production, you've probably learnt by heart how to customize an error message. And if you haven't, you should check your endpoints to see what the error messages actually look like. So what's wrong with and? This is the same example. You've already seen it. It is, we generate here and then filter out the generated values, but actually we'll never find an answer. But what's wrong with fun? We must manually override fun because it gives completely opaque error messages. So here's an example. This is, I am a string and I also include a, and you give it 1. So this has two problems. It should be a string and it should include a, but look at the included a error message. This is unknown error. And if you think about it, there's really no recovery. This is a program. This is a opaque program, this hash here, that says I'm a function that can do anything, basically. And yeah, I'm sure you're all writing in your heads, you need to put an error message in there, dummy. You put error/message or whatever it is. I consider that a workaround. For users, it should be part of the value proposition of Malli that you don't need to customize error messages 99% of the time. Now, there are existing examples of Malli using this approach, and min and max are the main ones. You have a property min that says how many characters a string can have, and also how many entries a map can have, and map, which is these bounds are inclusive, basically. And these work just fine because the generators know all about them. They actually have, and the humanizers, the explainers. So the error messages will be able to explain, you need more characters, you need less map entries, and did I say that right? The humanizers, yeah, and the generators will be able to not probabilistically generate strings of minimum 10, but actually by construction. They only start at 10 characters. They don't just say, well, let's generate all strings and take out the ones that are less than 10 characters. But as well as good as this is not extensible, it's not customizable. Whatever Malli supports is what you get. And often you want more than this. But this is a really inspiring starting point. This is a map. You can put anything you want in here. You can there's green pastures here. And if anyone's used spec, there's an interesting feature where there's actually a sort of propositional logic or constraint logic inside of spec itself. If you've used keys before, you know that you can have an or and an ands arbitrarily nested in keys. So you can say, I want a map that has a secret key or both a user and password key. And if you think about it, so this secret basically means it has a key secret and the value corresponding with secret is lookup secret in registry, which is secret string half. So this is basically, you could think of this as maybe contains. It either contains secret or it contains this or that. But contains is just, if you think in terms of like a constraint logic or propositional logic, you have atomic propositions and connectives. Let's see if yeah, and the atomic propositions are things like this, and the connectives are or and. And you can have all sorts of atomic propositions, all sorts of connectives. So that's sort of where I want you to think, like, oh, what else could I put in these constraints? How could I enrich my constraint logic? Yeah, so to follow on to that point, if we have Malli already has a way of collapsing. This doesn't happen automatically. You have to do this explicitly. If you want both a string that is at least 10 characters and no more than 20 characters, and you want it to be reliable, you simply collapse in the properties into the string itself. But why can't we do it with an or? There's not a strong reason to do it, but like let's think about it. It's either a string of minimum 10 or a string of maximum 20. Why couldn't we have an or property in here as well? If you think of this property map, it's an implicit conjunction. So it's not min or max, it's min and max. So if we were to try and embed a propositional logic inside of here, the top level would naturally be a conjunction. And then we'd have to add disjunctions or sort of on top of that. So you'd say, I want a string that's either minimum of 10 characters or maximum of 20, which I don't think makes any sense, but that's sort of, I'm trying to mirror I don't know why you'd write something like this, but I'm building up to some pretty amazing, specifications. And here's to really hammer home how hopeless it is to depend on probabilistically successful generators. Remember, if you have an and, we generate the left thing and then filter out any values that don't pass the right thing. And you could imagine maybe we're lucky, we'll find 740 every now and again. But look at this example. We want a double that's in between. Is there literally, yeah, you have to be in between these two doubles to find this number. This is a little silly, but and a little cheeky because I've actually pronounced this in two different ways. One is the straightforward way, and another is to sort of get your brain firing about, oh wow, this is actually a whole other world, which is let's use like De Morgan's laws and things like that to invert this constraint into something that is logically equivalent. And notice in my prototype, it also gives this number. So there's some really interesting things we can do if the driver is the schema itself, not the connectives. Okay, so we're talking about atomic propositions like min and max, and which meant like either number of characters, number of entries, and wow, this looked like a propositional logic or a constraint logic. Well, you can have a natural extension point for propositional logics is to add new atomic propositions. So I've just written out all of the ones that I can think of for, say, string, length, starts with, ends with, includes, serializes to, like as in, if you read this in Eden, it should give you this, like as in the number one in a string should serialize to an int, like how many code points, like emojis, change. This is sort of related to this, but say you want to count emojis or I don't know why you'd want to do this, but you could imagine if the Malli people didn't think you would want to do that, then you could do that. You could say, well, I want to add one for emojis that actually counts code points correctly because I care about that. Here's a really common one, non-blank strings, a string that doesn't contain a white space character, one that's alphabetic or numeric, one that has distinct characters. We're getting a bit obscure here, but one that, yeah, has trimmed white space on the right and left, one that only escapes certain characters, one that matches a regex, one that has upper or lowercase throughout, one that's a palindrome. And remember, I'm talking about atomic propositions. This is something that can be then combined with connectives and or not, and I will show you the other ones. So for maps, you'd have the ones we already have, min and max, and is that right? Yeah, contains is sort of the intrinsic, the natural atomic proposition. It's usually got sugar in it. The syntax is sugared. Like in spec, you just put the keyword and that says it must contain this entry. Whether it's sorted, you know, like maps have can be sorted. So maybe you'd want to say I only accept sorted maps. And numbers, you know, any sort of numeric comparison, even, odd, positive, negative, multiple of, probably not primes, but yeah, exactly. You could say I'm ready to do primes, so I'm going to extend it. So some of the connectives, or and, XOR implies not, if and only if, and I will go through all of these and um, motivate why you'd want some of them. And here's my party trick of, you know, how to generate 740. This is really a stress test, I guess. And I'll try and explain how this is done. Okay, so here's, this sort of looks like CSS padding, like maybe an Edenized version of a CSS map where you have top, bottom, left, and right entries about how much padding you'd want on the outside of your bounding box. And a natural thing is that you can only have padding, well, let's just say for the sake of this argument, that you wouldn't want a padding that has no elements. So you could say maybe there's a minimum of one element here, but that doesn't really, I don't know, there's something more granular here. Like maybe you'd have extra elements that you don't really, say you'd have like color as well, like it's completely optional. Actually saying you need one entry you'd be able to just specify color without top, bottom, left, and right. So yeah, I'm now reminding myself why this is, on the fly, I am telling you why this is a good example. Uh, but yeah, this is padding where you'd want at least top, bottom, left, or right. And remember, or is a connective where one or more of its constraints or propositions must be true. So you can give all four, you can give three, you can give one or two, any of those. So for example, if you give all four, we can validate a map that it is a instance of padding correctly. But another really, um, a really sort of great motivating case to sort of say what you mean here is that we can use this in the humanization of error messages. So say I'm trying to say, explain to me why the empty map is not a padding. And notice this is a powerful thing right here, this or. What this means is, in order to rectify this error, you must do one or more of these things. And you're allowed to do one or more. So any of these, but you're not allowed to do none. So because the empty disjunction is false. And like in Clojure, you give or with no arguments, gives nil. It's similar in logic. And that's sort of where the root is from, of those semantics. And oh yeah, the order, if you care about the order, so these, I'm learning a lot about the prototype that I wrote. So never mind. So the point is, it's actually really nice to use vectors here instead of say sets, because a lot of, that's one of the main reasons why Malli uses vectors, I think, in my opinion anyway, that you get deterministic messages like this. You'll always get it in this order. But I don't know whether you'd want to give this to a someone sitting on an endpoint, you know? I don't know. Maybe this could be, disjunctions are really kind of odd, especially nested disjunctions to convert into English. Like this is a really nice way of expressing it if you're familiar with the concept of or. But let's say at least at the REPL, a developer could learn pretty quickly that, well, I have to do one of these things. Okay. So OR has a cousin called XOR, exclusive OR. And you must, the way to satisfy an XOR is to have exactly one of its children be satisfied. So if you've used dep's Eden files, tools, deps, you'll have internalized that you can either give Maven coordinates or Git coordinates, and you're not allowed to combine them. So this map here codifies that intuition. So it's a map where you can have an optional version, which is a string, an optional char, which is a string, but there's an extra constraint. Either you give a Maven version or you give a Git char. And this is maybe, this is actually pretty good because you wouldn't want to have none of these given. It wouldn't make sense. You'd need some sort, oh, there's local root. So there would be one more here and you'd put one of these things and they're all, is local root, can it be combined? No, they're all distinct. So actually that's perfect. You put local root here as well. But yeah, you could validate that Maven version is a well-formed version of this map. And here's a really cool thing. This error message says XOR. So what this is doing, it's saying this map, explain to me why this map is not a valid coordinate for a Git or Maven. And it's saying, in order to rectify this problem, you must do exactly one of these things, but not both and not none. You should either not provide the Maven version, which that gives the Git char, or not provide the Git char and you get Maven version. But if you did both, you would get an error as well. Is this the same thing? Is it? No, okay, okay. Yeah, and this is the works in the reverse, right? Should not provide key, and if you give it neither of the keys, either you must provide the key Maven version, or you should provide the key Git char. But if you do both, then you're misinterpreting this XOR. This is, there's a lot of information here about how to rectify this problem. If and only if. So if and only if, all of the constraints must be satisfied or none of them. So here's a user password map that I'm going to sort of make variants of as we go. But here's one version of it where you either give no credentials or you give all the credentials. And you have a user, which is a string, a password, which is a string, and this is only this only describes values such that either both the user password are provided or none of them. So for example, if you give none, you can validate a map. If you give both, you get true. But if you give one, hey, look, XOR again, had nothing to do with if and only if. But this is what naturally comes out. If you want to rectify this problem that you've only given a user, you should either provide the key pass or not provide the key user. And I think if you do exactly one of those things and not both, is that right? Or is it, let me think. Can you? If you should not, yeah. Yeah. Let's run away from that. Okay, I think I might have a logic table at the end of this talk, but in form of Clojure of unit tests. Okay, here's another one. This is really cool. So you know that in dep's Eden files you can give a Git char, but you can also give a tag. But sort of not in all cases, but in most cases, if you give a tag, you have to give a char. But if you give a char, you don't necessarily need to give a tag. So this implication says if this is true, then this is true. And another way to think of that is either this is not true or this is, did I say that right? Yeah, or this is true. Yeah, exactly. That's why I like the sugar better than the expansion. So here's an example. It's fine to give a Git char. It's fine to give a tag and a char, but it's not fine to give just a tag without a char. And notice this error message has nothing to do with the impliers. There's some magic going on underneath, some sort of normalization, which I hope to learn what I did at some point. Uh, but look, we gave a tag without a SHA, and it said should provide key get SHA. That's the only way to remedy that. Okay, here's another. This one's kind of interesting. So it's related to sort of X or if and only if, um, but it's a little different. So again, going back to Depp's Eden files, there are lots of Maven commands. There are lots of Git commands. Actually, I can only think of Maven version. Let's imagine there's something else. But we effectively have two sets of keys that should never appear in concurrently, in the same map. Um, so, uh, so yeah, we have a version. All these can be strings with this additional constraint that this set of keys cannot coexist with this set of keys. And this doesn't say anything else about how many of these you're allowed. It's just basically like you can't have these, you can't have these, you can't have these. It's like a combinatorial combination of band combinations. So if you validate, you can have the empty map. This is true because, in fact, these two are disjoint. There are no keys that are present in either of these things. So the empty set is disjoint from the empty set. I have no idea. Is that true? Yeah. Yes. Thank you. Yes, the intersection is empty. Okay. This is true, the Maven version, because the intersection is empty between the keys that are actually present in the map. Whew, I'm bad at explaining this one. But if we provide both a Git and a Maven thing, now let's see, is this the best way to? Yeah, it's because it's not saying which one to remove. It's saying that the problem is the fact that so it could be an or of remove this key or remove that key, but actually this is much more precise. This is putting the keys in your hand, basically. Here's what the actual problem is. Where, like, yeah, you'd probably get two error messages to say, oh, yeah. I did put a colon here, so maybe this could have a commas, It could say like, yeah, but it would be an and. It would be and this message and the other. I don't know if we've seen an and yet, but maybe we have. But just to be clear, Malli has nothing like these keywords in the. This is sort of what the Malli humanization looks like, and it's a little confusing because there's vectors, but it's not. You don't really know what the vectors mean. Sometimes it's inconsistent. Disjunctions aren't really reified correctly in the error messages. You don't know whether something's a conjunction or a disjunction. So there's sort of there's a lot of overhauling that could be done here and specifying. And if these are all error messages about the top level, but if this was like nested in like 5 different vectors, then you would get more vectors on the outside here. And it gets pretty confusing. I'm not claiming I've solved that problem, but I think at least with my prototype, you'd have a 5 nested error message. And then at the point in which the disjunction is needed, that's where you'd see it. The or will be in the middle. So you'd be like, okay, so this element is wrong because of one of these reasons. And I think at the moment, a list of strings in Malli's humanizers can either be a conjunction or a disjunction, or it's not really well documented. I can't really remember. Okay, and this is a constraint logic. This is a propositional logic. You can nest arbitrary constraints. So directional pad, D-pad, Nintendo, playing, Super Mario. You can go up, down, left, or right, but I think there's a hack in speedrunning where you do both up and down. The little nub that holds the D-pad, you can naturally, either naturally or intentionally, chisel it away, so then you can press both up and down. I can't remember if it's in the current speed runs of the original Mario, but let's say we wanted to ban that at the spec level. Not sure what the semantics would be. Let's say it just drops the packet. But our representation here is a map that says down is it's either absent or it's one, left is either absent or it's one. So it's like a binary thing. But what we want to say is that both these keys are disjoint. You cannot have a down with an up, and you cannot have a left with a right. So you can have none. I actually, yeah, that's the default packet that you'd get from the hardware. You get up, down, right, left, up, left, up, right, down, right. This is all good. But if you do up and down, you get should not combine key down with key up. Left, right should not combine key left with key right. Trying to think of a Clojure. This is kind of cool enough, I gave the boring one that would work for Depths Eden. This is Nintendo. This is much cooler, right? So I don't need further. All right. So another sort of this is probably much more practical than I realize. So here's a very, very common here's a very common thing that you'd want to do. You'd either want to give a secret key or a user password. So either a secret or some credentials. Now, what have I written here? So there's a couple of things that so remember, the top level is a disjunction. So we're saying that we're allowed 3 keys, secret, user, and password, and both of these have to be true. So this is from the spec example. Either we give a secret or a user and password, and also we can't give any sort of combination. So we have disjoint sets of keys. So you cannot give a secret with a user, secret with a pass. There's probably other ways to pronounce this specification. Very subtle differences, maybe if and only if, but yeah.
Does the and need to be a key or a map? Or is it looking for a key called and?
Are you talking about this? So, okay.
Because in the other examples, the connectors are always keys in the map. Yeah. And then the keys.
Yes. Yeah, there's some sugar here.
Or is the first type of vector with little cheese on it?
Let's see. So I think there's really only one intrinsic. I kind of touch on this later on, but it's worth saying. So really, if you think of every constraint as an and property, so it's just that the sugar is that you can put the constraints in there, and the constraints go into the and, right? I can't really see it on the. Okay. But there's also sugar to say if you put or of constraints, then that becomes, you can say, put this in the and.
Okay.
But there's another layer here, which is when you say user in a map, what this actually is, it's sugar for a constraint called contains user. So there's like different levels. So the map, anything that's associative has an extra sugar, which is the plain keyword sugar, which usually you must, in my prototype I made, you must use that, that classic Malli, vector thing where you have the constraint here, and then you put children. But yeah, for maps, it makes a lot of sense to make the a naked keyword basically expand out to contains. And for all the connectives, there's some variant of this sugar where I think if there's a not connective, it actually doesn't make sense to have a vector there. So you can say not user instead of having to say not, notice how there's an extra, and has naturally many children. Right. But this is actually normalizes to a constraint, not user, that goes in this big conjunction. So yeah, but that's syntax stuff. I don't, that might be, I kind of like this, I don't know.
I can see that there's a grammar to it.
Yeah, okay. Yeah, so Joshua from Mexico, what do the creators think about your work on constraints refining? So Tommy, we both saw that Clojures together had a demand for Malli work, so we decided that it would make sense to find a project that worked for both of us, and then have me propose it. So this is actually this project has been co-proposed, and I'm one of the maintainers now, but Tommy has the final word. But if you go to Clojures together, you'll see my proposal is basically to pull apart my prototype and try and implement as much of it as I can. All right, let's see. Yeah, okay, this one has a fix me. It's not even, so remember this, yeah, you were saying, yeah, you had a question about the syntax, which I'll get to in a bit. Man, we're running out of time. I'll just run through. So combining all with disjoint. No, I can't think about this right now. But it looks cool, right? That's definitely more precise than what you can say in spec, but that is by design. Like Rich Hickey designed that on purpose in spec, but Malli is different from spec, so in many ways. And here's really the insane example, which is specifying a password that is not non-alphabetic, so it must contain an alphabetical character. It's not non-numeric. It has to have a numeric character, and it must include at least one of these characters. And if you try and validate the empty string, you get this conjunction. Should contain an alphabetic character, should contain a numeric character, should contain these substrings, and then should be at least 5 characters. And I think that's that min thing there. And okay, there's the architecture of this, which was sort of related to the syntax talk we just had, was that we have schemas like int and string. We have the syntax like the ands and the nots that we saw in the map. And then we have this constraint, which like would only work with one, like an atomic constraint that, which you can have like a one-to-many relationship here. So remember, min meant number of characters in strings and number of entries in maps. Well, we know that those are related, but actually you could have the same syntax mean 2 different things. And the power here is, this constraint here is just basically an identifier. It's the min character, the min number of characters constraint is an example where you have, this is where you create validators, humanizers, and generators. So for example, if you want, oh, here's a sort of the opposite thing. If you wanted two ways of saying the maximum integer, you could have the less than or equal or max. You only need to implement it once, and just make sure that you say integer recognizes this atomic proposition and this one. And you don't need to, this is sort of a trivial, like, but it sort of, it's one advantage of this architecture, separating out the constraints. And the context-dependent syntax, like you can have the maximum number of vector elements and maximum number of integer elements. These actually are different. They map to different constraints. You have maximum count, where the validator looks like this. The humanizer must have a length at least this. The generator knows that you need to put the maximum in the generator. And then with integers, it maps to less than or equal integer, which has a completely different validator, cannot be larger than x, and then plugs in the generator in the right spot. And here's sort of the real power. So all of these, maps, sets, vectors, seekables, strings, integers, doubles, and floats, they all want to have this logical connective and. That's sort of where all the power is. And this syntax maps to one constraint that the validators are kind of obvious. You create a predicate for each one of the constraints, and you just check the predicate. The humanizers and generators are not as obvious, and I'll try and give a quick overview. So for example, humanizing. Yeah, so we already saw some of the, actually, I won't give you a precise explanation of humanizing, but with all those examples, we saw that sometimes the or up here meant an or down here, or an if only if. So you need to think of each one of those connectives and think, well, if only if can be rectified with an XOR. So that's, you put that in the humanizer for if and only if, for example. You need to think of all those cases, and that's basically what the implementation looks like. So if and only if becomes XOR. We've already seen this one. And with generators, how did we generate 740, for example? I don't know if I give this, okay, this is actually about maps. So the idea is to satisfy the constraints in a way that the answer to generate is just immediate. For example, if you have a map that is X or A or B, to this helper constraint solutions returns a list of solutions. Like it's an or of ands, basically. Very similar to logic programming. But the first solution has A as present and B as not present, XOR. Remember, this is the truth table. A is not present, B is present. And then there's a bit more machinery to turn this into a generator. And disjoint, if A and B are disjoint, well, here's the subtle difference between XOR and disjoint. You're allowed to have both absent, one absent, or the other absent, but not both. If and only if, use a password, either both absent or both present, and implies AB. Either you can have A absent or both present. And then this one's kind of an interesting one. They're sort of similar. This one says B is present, and this one says B is present and also A is not present. I'm not quite sure which one's more specific, to be honest, because generative testing is all about shrinking to the smallest solution. So there's a bit more there. Like this is basically giving hints to the generator to say, maybe this is more specific, maybe, yeah. But usually a failure is in terms of a concrete piece of data. So maybe these aren't. Yeah, so this is something I need to think about. Okay, so thanks a lot for listening. I've had many months of encouragement and fruitful discussions with Santi, Noah, and Ben. And yeah, Clojure Together is funding this work between September in November in 2024. That's why we're here on the 20, whatever it is, 9th or 8th. And because I worked on this in April and I needed to hit the ground running, and you know, Labor Day is coming up, so I guess it'll be a bit after that that I start. But yeah, thanks for helping me do the talk-driven development part. Yeah, so any questions? Yep.
Something where you need to have a convention of this much, does it need to be, they won't be added? You have to say if this is true or false.
It needs to be what?
They won't, like say for max, does it need to kind of like be opposite, like the reverse? That needs to be
Yeah. So the question is, for every atomic proposition, do you need to also need to know the reverse operation? So for that 740 example, where the less than was the opposite of greater or equal to. Yeah, so yeah, and the answer is yes. And in practice, sometimes you don't have to do twice as much work, but you can apply De Morgan's laws to normalize things into, say, disjunctive normal form, which is an or of ands. And and if you have a not around everything, you can push it in using De Morgan's laws. And then you can have a sort of a simplification algorithm, which is basically what happens in the less than example, which is you have a not and then a less than. Well, that turns into a greater than or equal. Like that's sort of the canonical form. But there are points, or like if you negate an if and only if, there's a logical way of doing that. That you just need to think about those. But there are extension points for negations. So if you can have a humanizer for a map containing something and also a map not containing something. So the extension point is like, I want to teach Malli how contains works and also not contains, like as in logical connector contains, like not contains, not a new not a new atomic constraint, but it does need extra handling. Yeah. Did you have anything?
Yeah. Yes. Are the atomic constraints pluggable? Like if I have a constraint, can I just add it or do I need to contribute it to Malli?
Yeah, so the question is, are the atomic constraints pluggable? If I have my own fancy atomic constraint, do I have to ask Malli's developers to add it? And the answer is no. You don't need to ask. It is pluggable in the same way that registries are not pluggable. You give, in your options, you can say, I want this new atomic constraint, and I'm guessing it'll probably be like namespaced, like see all those names are probably reserved for Malli, like ands and ors and nots. They're not actually Malli.core/and, you know, but say if you were to do it, it would be namespaced. Maybe that's just like a hygiene thing where like users enforce that, because I don't think that's enforceable really. In the same way that you can make a schema that is not namespaced and put it in your registry, it's sort of, you're shooting yourself in the foot if you make that public. But usually Malli registries are private. So, but yeah, you can even, everything that I talked about here, that architecture that I'll just bring up, you can implement a new constraint. You need to tell it how to validate, how to humanize, how to generate, and then you can attach that constraint to syntax. So, and you can also do the same thing here. You can, well, this is probably more, you could have the same name in different, you know, your own schemas mean two different constraints, two different things. Yeah. Yeah.
So I guess tying this back to like we already have fun as a thing, right? And but the only thing you really do with fun is decorating with the error message. So is the proposition that like, instead of creating a fun based like atomic constraint, I implement the constraint here, like in the constraint box here, and then I have control over the validator and connector generator. So I can do a lot more than just say, throw this error message in. I can say, like, here's how to do it.
Yeah. So the question is, how does adding a constraint like this relate to the fun constraint, which was just a program? And like we were saying before, that error messages can be, you can decorate a fun with an error message. And actually you can decorate it with generators, and validators just fall out, you know. But there are sort of different sugars for generators, but you'd only really ever do this if you're using a hack, you know. So I think it's part of the smell. If you have a fun and you're using like 10 different workarounds to add a generator here and a message here and all that stuff, I think that defeats the point of the value proposition of Malli itself. So so it does replace the role of fun in most contexts. And I wonder if maybe in all of them, maybe it's a more powerful version of fun.
Instead of implementing a function which is by definition kind of a black box,
Yeah.
you're actually speaking Malli's language, which is constraints.
Yeah. So instead of implementing a fun, which is a black box, we're speaking Malli's language to take apart that black box into the different things that Malli needs in order to give you the features that you need. Yeah. All right. Oops.
This is just very tangentially related. Is coercion related to generation? Like, do you generate like using this as like the input?
Yeah. So the question is coercion related to generation? I'm not sure actually. I think of coercion more like a combination of validation and parsing, but it sort of brings everything together because coercion first tries to validate something. Well, it transforms it, right? You need to transform it, validate it, and maybe that's implicit with the transformation. And then give an error message if it's, so you use the humanizers, the explainers. And so actually generation is the only thing that it doesn't involve, you know.
Right.
Was there something I missed that's related to this? Okay. But I guess related to this, coercions are defined in terms of, where is it? Oh, that's a lot of slides. Coercion is defined in terms of parsers, explainers, and validators. So if you work around and, you know, destroy your, actually, I don't know if parsers are, but if you destroy your explainers, you're destroying your coercers, which is, which is when your users will start, you know, complaining. All right, let me just see if there's any. The new logical predicates you propose, how would you extend the generators for schemas supporting them? Yeah, so it would be, this example here. So we normalize all the connectives. We basically find solutions, manipulate the constraints, so then they're in this sort of disjunction of solutions. And then from here, there's a direct translation to the generators. All right, any other questions in this room? All right, I think we're done. All right, thank you. All right.